or while I'm writing, excuse me. This is one of these problems where it's a popular type of problem in that you don't have to solve directly for x in the initial condition here, but the initial condition gives you a lot of reducing power, so to speak. Now, so the first thing I'm doing right here is showing you how x cubed is just equal to a linear expression. Turns out to be quite useful because we're asked to evaluate x cubed divided by this 6th degree polynomial. All right, and of course, directly solving for x, theoretically you could do that, and then I think there's 3 zeros there, 1 real and 2 complex. You could substitute each of them in here and see what you got. But that, again, is computationally very onerous. This is the best approach right here, and it involves a long division. Now, what we do right here is we actually do a long division. I don't show you any of that work, but we divide this denominator here by the given information. And the reason is you know that this is going to wash out to be 0 at the end. It's very, very useful. And also it turns out when you do the long division, you get a linear remainder here. But the key part of this that really makes it fly, well, there's more than one thing, I guess, but you see here, first of all, we got x cubed equal to x minus 7, which will be useful here in just a second. But also, it's part of this quotient divisor piece right here. So this entire part will just be equal to 0, and the entire denominator is just equal to this linear part, all right, which is very powerful. Now, so if you keep on going right here, that's all I did is I incorporated those two things. X cubed is equal to x minus 7, wrote it right here, right? Okay, and then this piece right here, like I just stated earlier, is exactly equal to this by long division, which again is tedious. I made my share of mistakes when I was doing it, but I think I got it right here. Now, so this part just gets wiped out, and here we go, color-coded for your viewing pleasure. Now notice what happens right here is you get x minus 7 over 13 times x minus 7. Factoring a 13 out of 13x minus 91 gives you 13 x minus 7. 13 times the quantity x minus 7. Y'all, and notice as long as x is not equal to 7, this just reduces to 1/13. Okay. Again, if you need to see it, there's a 1 in front of this, right? So if you want to think of it, you need to see that step. Some people will, when they're first learning, don't notice that, but there's a 1 right there. So you see these x minus 7s do cancel, and you get 1/13 as the answer. But what we're tacitly assuming here is that x, no longer tacitly, x is not equal to 7. All right. For this cancellation to hold, x can't equal to 7, or you'd be dividing by 0, right? This is the answer because 1/13 is the answer. And it's the answer, you know, because 7 is not a solution up here, right? 7 cubed is what? A huge number, 343. So 7 is not a solution here. 7 not a solution. So it's this, assuming x is not equal to 7 is totally legitimate. And this is the answer, 1/13, as I mentioned. And again, just think of the computations. If you had to directly to solve this cubic, again, a lot of cubics have 1 real and then 2 imaginaries, and that's the case right here. You'd have to, you could substitute all 3 of those in here, but imagine what it'd be like to raise a surd, you know, just an irrational number to the 6th power. That's just tedious. It's not hard, but tedious. You know, I do want to thank this gentleman. His name is Falkenfurter, I guess, and he made a comment at Cybermath that the long division approach was better. That wasn't something that was shown by the Cybermath channel. He pointed that out as a 4th alternative here. And I really like this because you can create your own problems. I can pose this problem just by doing this long division more or less in reverse. You know, I just did this part of it first and made it fit, so to speak. So it's kind of fun. There's a reverse idea going on here where you can start with this statement and then just come back the other direction to solve the problem. So it's kind of fun. If you're interested in problem creation, his idea is a nice way to generate whatever kind of problem you want. The problem at Cybermath was a squared, I think. It was squared This is cubic. I mean, this is a 6th degree, but you could do it however far you want to go, But anyway, again, thanks to this guy for what he did, and I really like this problem. Hope you enjoyed.